Hi, I'd like to tell you about some recent numerical modeling work examining stable isotopes on Enceladus. As water vapor and other gases erupt from the ocean, light isotopes erupt more easily, which should make the plume isotopically lighter than the ocean, and make the ocean isotopically heavier over time. For carbon and CO2, the ocean is probably only slightly heavier than the plume. But if the current plume eruption rates have persisted over long timescales, then the CO2 in the ocean may have been isotopically lighter in the past. If we assume methane started with the same isotopic ratio as CO2, then a fractionation between these gases in the ocean can emerge over long timescales. However, the maximum we see here, around 2.5 per mil, is still much smaller than biological fractionation. So this process alone should not create false positive biosignatures. The D to H ratio of water may have evolved similarly, but even with persistent long-term eruption, the D to H ratio of Enceladus still seems consistent with an origin from comet-like building blocks. Thank you.